An open U tube of uniform cross section contains mercury. Let me stop there. Let's try to understand what's the meaning of it. It says there is a this is our U-shaped open tube. It's a tube. I have drawn intentionally a big one just for the sake of understanding. It could be a thin tube of uniform cross section. Assume that all these cross sections are uniform. Contains mercury. So you have poured mercury into it. Well, when you pour mercury into it, it settles somewhere such that it is equal in both the limbs. So you can see mercury in such a way that it is equal in both the sides, both the limbs. This is what the meaning of the first part of the problem, right? Let's go to the other part of the problem. What's the other part of the problem says? If 27.2 centimeter of water is poured into one limb of the tube. So what you have done now is from one side here you have poured water. So what this water will do? It obviously push this mercury down by a certain amount. As so, these are the mercury levels initially. As the mercury level goes down on the first limb, it obviously goes up on the other limb. So what we can see after a little time or else instantaneously is this water will occupy some space of mercury. Thus mercury will rise, the side it will rise. So I want to draw this diagram once again, probably to make it even more clear for you. Just draw a simple diagram for you. It's a U-shaped tube. Yeah. Initially the levels are equal. Now the level in one side is occupied by water, other side mercury rises. Other side mercury rises. So this is the initial level of the mercury here. It has gone down to this extent and this is being occupied by water. This is the initial level of the mercury on the other side. It is raised on the other side by the same value. That means here, if the mercury is down by y, here the mercury is raised by the same y itself. So, if you consider this point and this point, these two are the same levels. As the levels are same, the pressures are same. So if you call this as P1, if you call this as P2, you can say P1 is equal to P. What is the pressure at this point? This is due to this atmosphere P0 and this is due to this water. So what's the total pressure at the point P0 is? P1 is P0 and pressure due to this water, that is how much? Height of the water, density of the water and gravity. So that's the formula for the pressure HDC. Then what's the pressure at this point? This is also open to atmosphere, therefore there's a P0 acting. And on this point, height is nothing but mercury itself. That is height of the mercury, density of the mercury, and acceleration due to gravity. So I'm using a basic concept like pressures are equal if the heights are. This P0 and this P0 can be cancelled. So what is remaining is height of the water, density of the water into acceleration due to gravity is height of the mercury into density of the mercury into acceleration due to gravity. Acceleration due to gravity also gets cancelled. What's remaining then? height of the water. It is given in the problem that height of the water is 27.2 centimeter. Density of the water 1 gram per cc. I am writing everything in CS system. Height of the mercury from here, it has raised by, see, if it is here to here the levels are equal. From here to here there is a y, but you are counting from here, there is another y. Hope you got this right. From here, the level is only y, but you are calculating from here because this is the point you have taken into account. So, from the depressed level of the left side, on the right side, it is raised by y and y, that is 2y. The density of the mercury is 13.6 gram per cc. 13.6 is twice. That implies 2y is equal to 2. That implies y is equal to 1 centimeter because I have solved it in the CGS system. So if you look at the question a little carefully, how high mercury will rise in the other limb from its initial level. So where is its initial level? This is its initial level. It is where from it is initially there. As I said, initially it was here. So from here, it has been raised by only y. That y value is nothing but equal to 1 centimeter itself. It is raised by 1 centimeter. That's how we solve the first part of the problem, right? I think you need to relook if you have not understood why this is y and this is 2y. Be careful. Let's look at the second part of the problem. What is the difference in the liquid levels on both the sides? So the difference in the liquid levels is, again, you can take these 2 points as a reference, right? Delta H is height, from here is height of the water, that is 27.2. From here it is at height of 2y, y and y, that is 2 into 1 centimeter. So the difference in their levels is 25.2 centimeter. That's how we have to solve the problem. So this entire problem is very simple and depends on one small concept that whenever the levels are equal, the pressures are also equal. That's it. That's how we have to solve this problem. Thank you for watching.